Factor 9v minus 27. When we're factoring for these first few examples, we're factoring by removing the greatest common factor. So we're deciding what is the largest number that divides evenly into 9v and 27, and that would be 9. So we put 9 on the outside of our parentheses, and then we're essentially dividing each term by 9. So 9v divided by 9 is just v, and negative 27 divided by 9 is negative 3. So 9v minus 27 factored is 9 times the quantity v minus 3, and you can always check your answer by using the distributive property. Factor 15x plus 20x squared. So again, we're just factoring these particular problems by removing the greatest common factor. So the highest value or greatest common factor of 15 and 20 is 5. And remember, when we have variables, if it's present in both, we remove the one with the smallest exponent, which in this case is x to the first. So we put that on the outside of our parentheses, and we're going to divide 5x out of each term. So 15 divided by 5 is 3. I had 1x, and I took 1x out, so I don't have any x's left. So next I come to the positive 20 divided by 5, and that gives me positive 4. I had 2 x's to begin with, and I'm taking 1 out. So when you're dividing, you're really subtracting the exponent. So that means I have 1 left. So 15x plus 20x squared factors to 5x times the quantity 3 plus 4x. Our next example, 24v squared w to the fourth x to the eighth minus 6v to the ninth w to the seventh. So again, we're looking for the greatest common factor of 24 and 6 first, which is 6. And now remember, for our variables, it has to be in both. So I have v's in both, and the one with the smallest exponent is 2. So I'm taking out v squared. Both terms have factors of w, and the one with the smallest exponent is 4. And only the first term has factors of x, so I can't take out any x's. So now I divide each term by the greatest common factor. So 24 divided by 6 is 4. I had 2 v's. I took 2 out, so I don't have any v's left. I had 4 w's. I took 4 w's out, so I don't have any w's left. But since I didn't take any x's out, it remains unchanged at x to the eighth. Next, I have negative 6 divided by 6, which is negative 1. I had 9 factors of v, and I took 2 out, so I subtract, and that leaves me with 7. I had 7 factors of w, and I took out 4, so remember, you're subtracting, and that leaves me w to the third. Now that is the answer, but it's best if you don't show the coefficient of 1. It's just like when we express an answer as x equals, we don't put it as 1x equals, even though it means the same. So in your answer, it's okay to have the minus 1 here, and it's okay if you don't. Rewrite the expression by factoring out the quantity y minus 9. So we have 5y times the quantity y minus 9 minus 2 times the quantity y minus 9. So y minus 9, since you see it in both, is the greatest common factor. So we're going to take out the greatest common factor and we're going to divide it out of each term. So y minus 9 over y minus 9 is just 1, so that just leaves us 5y times 1, which is 5y. And for the second, the same. Y minus 9's reduce, and negative 2 times 1 is negative 2. So our answer would be y minus 9 times 5y minus 2. Order does not make a difference in your answer because we're really multiplying two values, and order doesn't make a difference when you're multiplying. So if you had written your answer 5y minus 2 times y minus 9, your answer would also be correct. Our next question says factor by grouping v to the third minus 5v squared plus 7v minus 35. In this class, we'll know to factor by grouping because we have 4 terms. And so we're going to group the first two together. And then the last two together. And notice I'm bringing the sign with it. So I put the positive sign or plus sign in the parentheses as well. So what we're going to do is remove the greatest common factor from each group. So in the first group, the only thing that these terms have in common are v's. And remember, you take out the one with the smallest exponent. So we take out v squared. So remember then again, we're subtracting exponents. So when I take out a v squared, it becomes v to the first. And for the second one, I have a minus 5. And since I took out two v's, there's no v left. In the next group, I look for the common factor of 7 and 35. And that's going to be a 7. So I write my positive 7 here. And I'm dividing positive 7 out of each one. So 7v divided by 7 is v. And negative 35 divided by positive 7 is negative 5. So notice, and this is not by accident, these factors are the same. So it's similar to our last example. So we have one more step, and that's to remove the greatest common factor, which in this case is v minus 5. So remember, we're going to divide v minus 5 out of each. So that would leave me with a v squared plus 7. Factor by grouping u to the fifth minus 6u to the third minus 2u squared plus 12. So again, we would know to factor by grouping because we have 4 terms. So we'll group the first two together, u to the fifth minus 6u cubed. And the second group together, negative 2u squared plus 12. So again, in the first group, what we have in common is the u, and the smallest exponent is 3. So when we factor out a u to the third, we remember subtract exponents, u squared minus 6. Now in the second group, if this is a negative in front, we're going to factor out a negative, and then the highest common factor of 2 and 12, which is 2. So now we're going to divide a negative 2 out of each. So negative 2u squared divided by negative 2 is a positive u squared. And positive 12 divided by negative 2 gives us negative 6. And again, we're feeling good about this because these factors are identical. So our last step, our greatest common factor is u squared minus 6. And remember, we're dividing u squared minus 6 out of each. So this would leave me with u to the third minus 2. Next, we're asked to factor z squared plus 3z minus 10. I wrote a little reminder that z squared is the same as 1z squared. So we're going to use a method that's either called the AC method, or some people call it the reverse FOIL method. Okay, so let's talk about the steps in all factoring problems that we're dealing with trinomials, 3 terms. The first step in all factoring problems, no matter how many terms there are, is to remove the greatest common factor. In some cases, we can remove a value. In other cases, the only thing that divides evenly into all the terms is 1, which is the case here. So what I'm going to do is make this a 1z squared so I can go through the explanation. So using the AC method or the reverse FOIL method, we take the leading coefficient, which in this case is 1, multiply it times the coefficient of our last term, or our constant in this case. 1 times negative 10 is negative 10. So next, I'm going to write down all the ways to get negative 10 in multiplication. 1 times negative 10, negative 1 times 10, 2 times negative 5, and negative 2 times 5. Now, what I'm looking for, if it exists, is the pair that adds to give me my middle term, which is positive 3. So I'm going to add these together and see if any of them give me a positive 3. So 1 plus negative 10 is negative 9. That doesn't work. Negative 1 plus 10 is positive 9. And again, that's not positive 3. 2 plus negative 5 is negative 3. And negative 2 plus 5 gives me positive 3, which is my middle term. So what I'm going to do, and it doesn't make a difference the order, I'm going to use these two to rewrite my middle term. So I have 1z squared. Now my middle term is 3z. So this is going to be negative 2z plus 5z. When I add those together, that gives me positive 3z. And I copy down my minus 10. Now I have 4 terms. So what we did before when we had 4 terms is factor by grouping. So I'm going to group the first 2 together and the last 2 together and do the exact same thing that I did before. In the first group, the greatest common factor is a z. So when I take out a z, that leaves me z minus 2. In the second group, I'm going to take out a positive 5. And when I divide by positive 5, 5 divided by 5 is 1, so that gives me 1z. And negative 10 divided by positive 5 is negative 2. And again, important to note that these have to be identical or you've done something wrong. So next, we take out our greatest common factor, which is the z minus 2. And when we divide that out of each, that gives us a z plus 5. So z minus 2 times z plus 5, if we were to distribute, would give us z squared plus 3z minus 10. So you can always check your answer by using the distributive property. We're asked to factor x squared plus 13xy plus 36y squared. So again, the first step in all factoring problems is to see if anything divides into all three. But in this case, again, the greatest common factor is only 1. So I go to my AC method. So remember, my leading coefficient is 1, so I'm multiplying 1 times positive 36. And I'm looking for the factors of positive 36 that add to a positive 13. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Notice I'm using only positive factors. Why? Because I want a positive 36 and my middle term is positive. So to get a positive, the signs have to be the same. And so in this case, since the middle term is positive, they both have to be positive. So again, I'm looking for the pair, if it exists, that adds to a 13. And the pair that does is 4 and 9. Now, if there were no two factors that add to our middle term, then our expression is not factorable, or we call it prime. So now what I do is I take those two in any order and I rewrite my middle term. So notice my middle term in this case is xy. So I put plus 4xy and plus 9xy, and then again plus the 36y squared. So since I have 4 terms, I'm going to factor by grouping. In the first group, the only thing they have in common is x. So I'm going to factor out an x. And when I divide x squared by x, I get x. And when I divide positive 4xy by x, I get plus 4y. Now the greatest common factor of 9xy and 36y squared would be a positive 9, and they both have y's, so I'm going to factor out a y as well. And we know what this should be inside parentheses. It should come out to be the same. So 9xy divided by positive 9y is x. Positive 36 divided by positive 9 is positive 4. And remember, I had 2 y's. I took 1 out, so I have 1 left. So my greatest common factor is x plus 4y. And when I divide that out of each, I have x plus 9y. Factor completely 5u squared plus 45u plus 70. Remember, the first step in all factoring problems is to remove the greatest common factor. In this case, 5 can divide into 5, 45, and 70, so we're going to remove the 5 from each. So when I divide a 5 out of the first, that leaves me a u squared. Positive 45u divided by 5 is positive 9u. And positive 70 divided by 5 is positive 14. So what we do next is determine whether or not what's inside parentheses can be factored further. So what you can do is move this 5 down to the bottom temporarily and focus in on the u squared plus 9u plus 14. So again, we're going to use that AC method. So we take the 1 times the 14, and that gives us positive 14. So we're going to write down the factors. And again, I'm only using positive factors because the signs have to be the same in order to give me positive 14. And my middle term here is positive. If it were negative, then both of these would be negative. So now we're looking for the pair, if it exists, that adds to 9. And the pair that adds to 9 would be 2 and 7. If neither one added to 9, then our answer would have been what we did by just factoring out the greatest common factor. But now we rewrite using 2 and 7 to rewrite our middle term. Next, we factor by grouping. And in the first group, we can take out a u, and that would leave us u plus 2. And in the second group, we can factor out a positive 7. And remember, it should leave us the same. So 7u divided by 7 is u. And positive 14 divided by positive 7 is positive 2. So our greatest common factor is u plus 2. And when I divide it out of each, that leaves me a u plus 7. So all I've done is move the 5 down to the bottom because it still plays a part in our answer, and that just goes in front of our factored expression. So our final answer is 5 times the quantity u plus 2 times the quantity u plus 7. Factor 2y squared minus 9y plus 7. So again, our first step in all factoring problems is look to see if we can take out anything. So the greatest common factor of 2, 9, and 7 is 1. So next, we use the AC method. So I start by multiplying the 2 times the positive 7, and that gives me positive 14. So when I write down the factors, remember the signs are going to be the same, but in this case, they're going to be negative since my middle term is negative. So negative 1 times negative 14, negative 2 times negative 7. So the pair that adds to my middle term would be negative 2 and negative 7. So now I rewrite my expression, 2y squared minus 2y minus 7y plus 7, and then we factor by grouping. So in the first group, 2 goes into both, so we take out a 2. They both have y's, so we take out the one with the smallest exponent. So 2y to the second divided by 2y is just y, minus 2y divided by itself is 1. In the second group, remember if this is a negative, we're going to factor out a negative. And 7 goes into both. So remember, we should end up with y minus 1 at the end. So negative 7y divided by negative 7 is positive y. And positive 7 divided by negative 7 is negative 1. Our greatest common factor is y minus 1. And when we divide that out of each, that would leave us a 2y minus 7. So our final answer would be the quantity y minus 1 times the quantity 2y minus 7. Factor 3z squared plus 7z minus 20. So we're looking for the greatest common factor of 3, 7, and 20, which again is only 1 in this case. So now we use the AC method, and we're going to multiply the 3 times the negative 20, which gives us a negative 60. So we're going to write down the factors of negative 60. And we're going to look for the pair that adds to a positive 7. So the pair that adds to a positive 7 is going to be negative 5 and positive 12. So we're going to rewrite the expression using negative 5z and positive 12z to rewrite our middle term. We're going to factor by grouping. So in the first group, the greatest common factor is just z. And in the second group, the greatest common factor, and we're looking at 12 and 20, is 4. And it'd be positive 4. So remember, it should come out with 3z minus 5. So positive 12 divided by positive 4 is positive 3. And negative 20 divided by positive 4 is negative 5. So next, we take out our greatest common factor, which is 3z minus 5. And we're dividing that out of each term. And that would leave us with z and plus 4. So remember, you can always check your answer by using the distributive property. So our final answer in this case is 3z minus 5 times z plus 4. Factor 14z squared minus 5z minus 6. So again, the first step is to look to see if anything divides into 14z squared, 5z, and 6. And there's nothing but 1 that does. So now we use our AC method. So I'm multiplying 14 times negative 6. And that gives me negative 84. So you can write down all the factors of negative 84, but to save time, the pair that adds to a negative 5 would be a positive 7 and a negative 12. Because 7 times negative 12 gives me the negative 84, and when I add the two together, it gives me negative 5. So next, I would rewrite my middle term using positive 7z and negative 12z. Then we're going to factor by grouping. And in the first group, the greatest common factor of 14 and 7 is 7. They both have z's, and the one with the smallest exponent is z to the first. So 14 divided by 7 is 2. I had 2 z's, I took one out. And for the second one, 7z, any number divided by itself gives me 1. Now for the second group, remember this is a negative, so I'm going to factor out a negative. And the greatest common factor of 12 and 6 is 6. So negative 12z divided by negative 6 is positive 2z. And negative 6 divided by itself is positive 1. So the greatest common factor is 2z plus 1. And I'm going to divide that out of each term. And when I do that, that leaves me 7z minus 6. Factor y squared plus 2y plus 1. So again, we look to see if anything goes into y squared, 2y, and 1, and the only thing that does is 1. So we can use the AC method. Remember, there's a 1 in front. So I multiply 1 times 1, and that gives me positive 1. And the factors of positive 1 that add to 2 would be 1 and 1. So I rewrite my middle term using 1 and 1. And then I factor by grouping. So in the first group, the greatest common factor is a y. So when I divide a y out of each one, that leaves me y plus 1. In the second group, the only thing that goes into 1y and 1 is 1. And when I divide that out, that also leaves me y plus 1. So y plus 1 is my greatest common factor. I'm going to divide that out of each term. And when I do that, that leaves me with a y and a plus 1. So I have y plus 1 times y plus 1, which is the same thing as y plus 1 squared. So we call this a perfect square trinomial.